standard deviation and coefficient of variation. Range, quartile deviation and mean deviations are measures of dispersion and find the spread of the data, but have some disadvantages and limited applications. Standard deviation and coefficient of variation is, therefore, an improved measure of dispersion of a given dataset. Standard deviation is the most important and commonly used measure of dispersion. It measures the spread or variability of a distribution. It is a standard measure of the deviation of the entire data in any distribution. It is generally denoted by S. It uses the arithmetic mean of the distribution as the reference point, and normalizes the deviation of all the data values from this mean. A small standard deviation means a high degree of consistency in the observations as well as homogeneity of the series. Standard deviation measures the spread of the data from the mean. Here spread is important, whether the inclination is towards the left side of the mean or the right side on the distribution curve is not important, so the value of standard deviation is always positive. Standard deviation on group data. Standard deviation on group data. Standard deviation group data. Deviation group data. Merits of standard deviation. It is rigidly defined and has a definite value. It is based on all observations. It is not affected much by sampling fluctuations. Demerits of standard deviation. It is not easy to calculate. It is not easy to understand. It gives more weight to extreme items. Illustration, standard deviation. 1. Find standard deviation and coefficient of variation for the following data: 12, 5, 17, 10, 11. Solution. Comparison between mean deviation and standard deviation. Mean deviation. Standard deviation. Mean deviation is found using all measures of central tendency mean, median, mode. Standard deviation is found using the measure of central tendency mean only. Absolute values are taken to find mean deviation. Squared values are taken to find standard deviation. It is less frequently used as it is not capable for further algebraic treatment. It is most common measure of dispersion and very frequently used. If the data has a greater number of outliers, this measure is used. If the data has a lesser number of outliers, this measure is used. Exercise 4. Overview of skewness. A distribution is called symmetric if it looks same from the right and left side from the center of the data. It's called normal distribution and it look like. Skewness is the degree of distortion from the symmetrical bell curve or the normal distribution. It measures the lack of symmetry in data distribution. For skewed distributions, it is quite common to have one tail of the distribution considerably longer or drawn out relative to the other tail. There are two types of skewness: positive and negative. If bulk of observations is in the left side of mean or the central value of the data, positive side of the distribution is longer, it is called positive skewness of the distribution. In this case, mean and median are greater than mode. Example, the distribution of household incomes in the U.S. is right skewed, with most households earning between $30,000 and $70,000 per year but with a long right tail of households that earn much more. If bulk of observations is in the right side of mean and the negative side is longer, it is called negative skewness of the distribution. In this case, mean and median are less than mode. Example, the distribution of the age of deaths in most populations is left skewed. Most people live to be between 70 and 80 years old, with fewer and fewer living less than this age. Measure of skewness. Measure of skewness is beta 1 equal to skewness, equal to mu3 square by mu2 of 3. Where equal to third central moment equal to fx minus x of 3 by n and equal to second central moment equal to fx minus x squared by n. The direction of skewness is measured by sine of beta 1, where the sine of beta 1 is the sine of beta 1 equal to 0, beta 1 greater than 0, beta 1 less than 0. Carl Pearson's measure of skewness equal to mean minus mode by standard deviation. Kurtosis. Kurtosis is another measure of data, which describes the shape of the distribution. Kurtosis is about the tails of the distribution, thickness or flatness of the distribution. It is used to describe the existence of extreme values in both the tails. It is actually the measure of outliers present in the distribution. The distributions, whose peaks are same, as of normal distribution's peak, are called mesocritic. The distributions, whose peaks are higher and sharper than mesocritic, which means tails are fatter, are called leptocritic distributions. Here, due to more data in tails than normal distribution, this appears to push the tails towards central portion. The distributions, whose peaks are lower and shorter than mesocritic, which means tails are thinner, are called platycritic distributions. Here, due to less data in tails than normal distribution, this appears to push the tails away from the central portion. The distributions, whose peaks are lower and shorter than mesocritic, which means tails are thinner, are called platycritic distributions. Here, due to less data in tails than normal distribution, this appears to push the tails away from the central portion. Measure of kurtosis equal to beta 2 equal to, where equal to fourth central moment equal to fx minus x of 4 by n, and equal to second central moment equal to fx minus x squared by n. 2 equal to 3 mesocritic distribution, beta 2 greater than 3 leptocritic distribution, beta 2 less than 3. Note, in a symmetrical distribution mean deviation is 4 by 5th of standard deviation. Illustration, skewness and kurtosis. 1. The following data is of heights of 100 students. Find A skewness, B kurtosis. Solution. Exercise 5. Summary. Statistics in the plural senses means collection of data, presentation of data, analysis and interpretation of data. In practical situation many times we need to collect the numerical data of different variables, like income, expenditure, stock prices, GDP, population, marks, temperature, height, weight, blood pressure, etc. and analyze it to know the pattern and for forecasting and predicting the future data. To understand the collected raw data, first it should be presented in suitable form. The raw data is divided into different groups or classes and represented in a form of a table. This is called classification and tabulation. Limitations of statistics. Definitions of discrete and continuous frequency distribution, class limits, class boundaries, class length, relative, percentage, cumulative frequencies, frequency density. Central tendency is the most common and widely used statistical tool for analysis. The tendency of data to cluster around a central value is called central tendency of data. There are three measures of central tendency: mean, median and mode. Mean is of three types: arithmetic mean, geometric mean, harmonic mean. The arithmetic mean is appropriate if the values have the same units, whereas the geometric mean is appropriate if the values have different units, and harmonic mean is appropriate if the data values are in fractions or ratios of two variables with different measures, called rates. Arithmetic mean greater than harmonic mean greater than geometric mean. AM into HM equal to GM square. Arithmetic mean can be calculated for a series that includes positive, negative or zero values. Geometric mean can be calculated for a series that includes only positive values. Harmonic mean can be calculated for a series that includes negative values, although it is impossible to compute when the series includes a value of 0. Summary continued. Median divides the observations into 2 equal parts and quartiles divide the observations into 4 equal parts. The most repeated value in a given set of observations is called mode. Mean is appropriate for normally distributed data, whereas median and mode are appropriate when the data distribution is skewed. Mean is highly affected by the extreme values, median is not much affected by the extreme values, mode is not affected by the extreme values. Measure of dispersion is another property of a data, which means spread or variation of the data. Absolute measures of dispersion. An absolute measure of dispersion contains the same unit as the original data set. 1. Range. 2. Quartile deviation. 3. Mean deviation. 4. Standard deviation. Relative measures of dispersion. The relative measures of dispersion are used to compare the distribution of two or more data sets. These measures are unit-free. 1. Coefficient of range. 2. Coefficient of quartile deviation. 3. Coefficient of mean deviation. 4. Coefficient of variation. Skewness is the degree of distortion from the symmetrical bell curve or the normal distribution. It measures the lack of symmetry in data distribution. Kurtosis is another measure of data, which describes the shape of the distribution. Kurtosis is about the tails of the distribution, thickness or flatness of the distribution. Please click the above Enter Quiz button to check your skills.